Good morning, everyone. Let's go ahead and get started. Please excuse, you might hear some construction noise in the background, but my name is Nicolette Gia, and I'm the Senior Director of FreeClimb's Go-to-Market. So we're here today to talk about using RAG systems for RFPs. If you're not familiar with FreeClimb, we basically solve complex communication problems at scale. I'm just gonna let this person in. There we go. All right, as I was saying, we at FreeClimb solve complex communications challenges at scale, and we're here today to talk about using RAG systems for RFPs. I've got two great experts here with me today. We have Vijay Gurbani, the Chief Data Officer at FreeClimb. Good morning, Vijay. Just a little bit about Vijay. He has authored and co-authored over 75 papers, 5 books, 19 Internet Engineering Task Force RFCs, and been granted 9 patents by the US Patent Office. In addition to being the Chief Data Officer, he's also a Research Associate Professor of Computer Science at Illinois Tech and holds a PhD from Illinois Institute of Technology and master's and bachelor degrees in computer science from Bradley. Joining Vijay is John Parkinson. John is the Senior Director of Emerging Technologies at FreeClimb. He is the published author of 5 books and a regular contributor to CIO Insight, CFO Online, and HBR Online. He really works to shape the leadership at the intersection of AI and technology, and some of his past gigs include CTO positions at Capgemini, TransUnion, Ernst & Young, and Axis Capital Holdings. His degrees are from Exeter University in the UK, and we're happy to have him here today. Thanks, John. All right, gentlemen, welcome. We're going to go ahead and jump right into our topic, using RAG systems. And if anyone has questions, please go ahead and put them in the chat, and we'll cover those at the end of the session. All right, here we go. So my first question is for John. John, with RFPs, what problem are we even trying to solve?
So at FreeClimb, we are primarily a software engineering business. So we use AI to help improve the productivity of our engineering teams. And we build platforms that incorporate machine learning and large language models as part of what we do to support voice-based communications. But we're also always looking for ways that we can apply these rapidly developing technologies to other business processes here and at our customers. So one of the things that we, like a lot of other businesses, encounter is the need to fill in requests for information, requests for proposal, compliance audit documents that repeat on a regular basis. And if you have a lot of customers who require you to do this, they basically send you something very similar every year or every 6 months. And then we have to go collect the information, which is mostly in a scattering of documents around the business, pull the right answers together out of these documents, and then create a new set of documents to send the answers back. This is a time-consuming, frustrating, and unfortunately often error-prone process. So we were interested in, could we take the kinds of techniques that we've developed with machine learning in other areas and apply them to the problem of assisting, probably not completely automating, the process of responding to RFPs. The good news for us, of course, is that we have a bunch of previously collected and vetted responses, which are mostly digital documents, so they're available online. And if we can figure out how to find the right answers in them, train a model to go look for the right answers, then we can make the process run more smoothly.
So using AI can absolutely play a big part in this. It can know your business and help with this painstaking process?
Yes, it can. So we use an approach called RAG, Retrieval-Augmented Generation, to give the models, which are generally trained on more generalized data sets and may not have ever seen the specialized information that's required for us in particular to fill in the response documents. We point the model at a body of knowledge that should contain all of the answers that we need, and we train it to figure out how to go find them, how to assemble responses from them, and then how to keep a record of where they found things, so that the human reviewers who will need to look at this at the end of the process can be sure that they looked in the right place and found the right thing.
Interesting. So Vijay, a question for you. How is this RAG approach applied?
Okay, so as John said, we use an LLM. That's one of the main components in Retrieval-Augmented Generation. So talking about LLMs, I think it's interesting to understand where they derive their linguistic capabilities from, so to speak, because the answers that they generate are natural language answers, right? So as a thought experiment, consider that GPT-4 was trained on about 13 trillion tokens. So a token is part of a word, so 13 trillion tokens is about 9 trillion words, right? So keep that number in mind. Now consider that an average New York Times bestseller is between 60 to 100,000 words. So let's say 90,000 words. If a person reads 2 New York Times bestsellers between the ages of 20 years to 80 years, so in 60 years, if every month they read 2 New York Times bestsellers, they would have read about 129.6 million words. So clearly, the capacity to absorb the words, understand the grammatical structure, understand the lexical structure, understand which words go together, understand which sequence of words go together, these LLMs are highly exposed to, right? So it makes sense to use these as one of the important components in the RAG system. So that's the LLM. Now, how is RAG applied? As John said, the information that we use for RFPs or other purposes are spread out across various documents in different representations across the data lakes that enterprises have. So I might have a document in MS Word, I might have a document in PDF, in text, in some proprietary format, in CSVs, XLS spreadsheets, and furthermore, I might have information that is tabular in nature or graphs. So the first thing we need to do is to take all of this information and sort of textualize it, because LLMs generate tokens, right? Words. So we now need to convert all this information into individual words. So we use a process called chunking that essentially goes through each of these documents and extracts the information and then creates that information in form of words. These words are then converted to tokens, and we then essentially do what's called embedding. So we take this chunk and we embed it in a high dimension vector space. In our cases, we typically use a dimensionality of about 1024 dimensions. Now, taking this chunk and putting it in this high dimensionality has some advantages, because what it does is it preserves the contextuality of the words that come together and allows this LLM at a later point to try to make some interesting intelligent synthesis out of the chunks that it's retrieving. So once we've taken this embedding, we store it into a vector database of some sort, and there's many open source as well as commercial vector databases like Chroma, Milvus, Pinecone, and the like. So you take the information, chunk it, put it in this vector database. One thing you have to realize while chunking it is that two things are important. One is the chunking strategy, and two is the embedding algorithm we are using. The chunking strategy is, are we going to essentially take each page and consider that as a chunk, or are we going to overlap one or two lines of the current page from the previous page to preserve some context. So there's some decisions you have to make there. The second thing is an embedding algorithm. I think this is a very important aspect of a RAG system that sometimes doesn't get as much notice, because the embedding algorithm is essentially what is giving you this dense connection between the words and how they relate to each other. So if you want to use some really good dense embedding algorithm like BGE, as opposed to something sparser like TF-IDF, for instance, you're better off using something that preserves the contextual information in these documents. So you have your chunked knowledge, you've transferred it into embeddings, you've stored these embeddings into a vector database, and you've chosen your LLM. The choice of LLM is also important here, and it's really a function of what you're trying to do with the RAG. If your RAG is going to be serving just frequently asked questions, then a smaller LLM like a 32 billion parameter LLM suffices. On the other hand, if you are going to ask your LLM to actually do some intelligent synthesis from the chunks it's getting, then you need to use an LLM that is far more capable, something like 70 billion parameters to maybe 120 billion parameters. Again, you also have to understand whether we're going to run this in-house, in which case we want to use the larger end of these LLMs that can run in-house, or use a cloud-hosted LLM of some sort. Sometimes information that we are trying to give to our customers might be proprietary, and we might not necessarily want to upload that at the cloud. So then you choose your LLM, you choose your vector database, you have a chunking strategy, you have an embedding model, and those are the artifacts that go into your RAG system. Once your RAG system is ready, a user can call in, or a user can go to a website and start typing questions. And what then your RAG system does is it takes the user's query and then goes to the vector database, and it embeds the user's query using the same embedding scheme, and then tries to compare the embedding resulting from the user's query with the chunks that it has in its database. And then it might surface, let's say, top K matches, where K might be 5 or K might be 3. And these top K matches then are provided to the LLM as contextual input, so that the LLM can then synthesize a response based on the context that it got. So that, in a very high level, is how these RAG system work.
So Vijay, question for you. My favorite thing that you said in this, by the way, was chunking strategy. I love that. Will you hit me one more time about those major components of the RAG system? I heard the chunking strategy part loud and clear.
Sure.
What are the other components?
So one is deciding on a chunking strategy. 2 is deciding on an embedding algorithm. 3 is deciding on the choice of your LLM, on specifically the number of parameters, which will be dictated by the complexity of the RAG system that you're creating. So those 3 components are what will go into, and obviously, I think I said a vector database. So those 4 components, chunking strategies, vector database, LLMs, the choice of the specific project that you're trying to do would be the inputs to a good RAG system as you architect it out.
Excellent, thank you. So question for John. Vijay just outlined the approach that can be tried out. What are some of other challenges with this approach?
Well, there are challenges with anything you try and do with software technology. For RAG, the 3 main challenges are latency. We are trying to speed things up. So while we don't have to make the RAG work in real time or even near real time for this specific use case, speed does matter, and we can generally tolerate a delay of a few seconds when the manual process we're replacing would have taken hours or days. So we focus on trying to make things go quickly, but we're not as constrained as we would be if we were having to deal with real time. All LLMs depend on the quality of the data that you use to train, test, and tune them. So we have to worry about how good those documents that we're going to turn into embeddings in the vector database actually are. So some upfront human review is necessary. And if the documents change frequently, for our use case, they generally don't. But if the documents change frequently, then the review would have to be repeated on a fairly regular basis. And then provenance. You should be able to understand where you got the answers from. For audit reasons and for confidence building reasons. So an end of process human review should be able to sanity check that the LLM got the answers right in a consistent basis, didn't hallucinate or didn't make mistakes. Those are the kind of three main challenges. And there's always the challenge of the cost of inference, that we are running this, we run these things, generally speaking, in-house, but there is some cost associated with whatever platform approach you use, and it should be commensurate with the value that you're delivering by reducing the amount of effort to produce the response to the RFP.
Okay, interesting. So data quality, latency are things to definitely think about and be cautious of. Provenance, but this system actually assists with that, even though the human element is still wise. And
yeah, a reviewer can always find where the answer came from. In some RAG systems, that's not the case, but in the approach we took, it will always be the case that you can verify the source of the answer.
You can find where it came from. That's everything. Pre-auditability. Excellent. Okay. Vijay, can you talk a little bit more about some of the things we had to solve for in this process and techniques we developed to get that right answer, that one-to-one provenance, and build that auditability for human reviewers?
Yes, of course. So one of the first challenges was that if you take a look at the RFP process, because we are responding to requests for proposals, we do not want the LLM to hallucinate. And depending on who you talk to, some people say LLMs always hallucinate, except if you like their hallucinations, then the answer is right. If you don't, then the answer is wrong. But all kidding aside, we would like to get to the point where the LLM is not manufacturing information, where it is not warranted. So we started taking a look at these embedding schemes and started to evaluate, would only a dense embedding scheme make sense, or would only a sparse embedding scheme make sense? Or, as we ended up doing, would a hybrid embedding scheme make more sense? So we ran various experiments, and what we found out was that while a dense embedding scheme gives you good answers, and a sparse embedding scheme also gives you answers which are not as good as the dense embedding scheme, if you were to merge them and create a hybrid embedding scheme, that actually gives you the best answers. So one of the things we did was to come up with this hybrid embedding scheme. And in fact, we described all of what I'm talking about, including the code for our provenance, in a paper that was presented in October 2024. Yes, October 2024, at an AI ML conference at the University of Louisiana. And I will actually post the link of the paper in the chat when I show one of the results from the paper. So taking this hybrid embedding scheme was the first challenge, right? The hybrid embedding scheme gave us good results, and it reduced what's called no context in this particular domain. So let me explain this idea of no context. Because we don't want these LLMs to hallucinate, what we typically do through prompt engineering is say that you're going to be provided some documents, and these are the documents that we retrieve from the vector database, as I said, by matching the query to the chunks stored in the vector database. So we tell the LLM that you're going to be provided some documents and restrict your answers to the information present in those documents, and don't try to come up with any manufactured information. So consequently, as the LLM follows the instructions, if the information that it is being asked to look for is not there in that contextual information that was provided to it, it'll come out and say that there's no context. I cannot answer the question. So one of the things we noticed was that our hybrid embedding scheme actually reduced the no context from almost about 4% no context answers to less than 1% no context answers. So that's a big lift, because if your people are asking questions, then you do not want the LLM to come out and say that, well, I can't answer that question. So working on this hybrid embedding scheme allowed us to reduce the no context. The second thing, as John alluded to, is provenance. Many RAG systems give you the information, but they don't necessarily give you the reference from where that information came. And there's a reason for that. Consider a document. A PDF document or an MS Word document will have some meta information associated with that document. One of the most important meta information is the page number or sections, for instance. Or if it's an XLS spreadsheet, then it might be the row or the column or the tab. This meta information needs to be preserved across the chunking mechanism, so that when we say that this question came from this section on this page, we can actually go back and the user can go to that document and look at that section and look at that page and said, yes, indeed, this information did indeed come from this page. So provenance is very important, and the artifacts that lead to provenance are actually kind of lost during the chunking process, because the chunking process is taking a well-formatted document, turning into just pure text, so it can create the words that would then be fed into the database, and the vector database. So one of the algorithms that we came up with, again, this algorithm is in the paper, is to come up with a store where we stored the chunks and their meta information from where this chunk is coming from. Then when the user makes a query, we take the query, we embed it, and then we start searching our chunks and start retrieving the meta information so that we can give a reference from where that answer came from. Now, another thing we found out here was that when we take the user's query, or when we chunk this information in order to store it in the database where we could go ahead and find references for it, the dense embedding scheme actually didn't work as well as the sparse embedding scheme like TF-IDF. So for just the provenance part, where we are extracting the page number and the reference, we ended up using a sparse embedding scheme like TF-IDF. And that makes sense, because essentially TF-IDF tries to see what terms are being searched for, how common or how rare they are across the corpus of the documents that we have. So for our provenance, when we tell you that this answer came from section 4.2 of page 5 of this document, we do an embedding process, but that embedding process is done using only TF-IDF as the embedder. So that's the second challenge that we had to come up with. So essentially, provenance and reducing this incidences of no context would be the two very important challenges that we had to face in this particular project. Because remember, if you're doing RFPs, yes, there's a human in the loop, but the computer is generating the answers. And what we want to do is to try to focus the human's attention on those answers that need to be expanded more. So by providing these references, we can focus the human to look at those references and see if anything that the AI generated needs to be improved upon manually. So hopefully that gave you a little bit of an idea of the challenges that we faced as we tried to create this verifiable and efficient rack system.
Absolutely, and one that can again give you that provenance and that auditability for really highly constrained situations where correctness absolutely matters. So you mentioned this a little bit, Vijay, but just to circle back, did it work? How'd it work? Were you happy?
We are happy, and apparently the reviewers are happy as well, because we did publish a paper on it. So I'm going to now share my screen, and I'll point the viewers towards a table in the paper. So give me just a few seconds.
Thanks, Vijay. And we'll make sure we share out this paper with everyone along with the webinar recording.
Please let me know when you can see the table.
We can see it.
Okay, great. So this is the table. We had two clients. Client A was mostly a yes/no answer. Client B was a rack system that was more complex and required more complex answer and required the LLM to actually synthesize information and generate longer answers. So as you can see, the accuracy in our hybrid is much better. In fact, all of these are much better in the hybrid mode than only the dense mode, outside of precision, which I'll come to in a few minutes. So if you take a look at this table, this is basically saying that our no context, which to us was a very important component of evaluation metric, again, since we want the LLM to actually give you an answer instead of throwing its hands up and saying that I don't have an answer. So our no context rate went for this client that had yes and no answers from about 4% to less than 1%, and from this client that had longer synthesized answers from about 0.5% to 0. So clearly the jump, here is substantial. The jump here might be small, but again, anything that we can do to make the human examiner's life easier would be a win for us. So reducing this no context rate was definitely one of the prime directives. Now, precision and recall. Precision, as you all know, is essentially what percentage of the true positives have been predicted are indeed true positives. And recall essentially is, of all of the actual true positives, how much did the model find? So as you can see, recall is higher here with the hybrid. No context is higher here with the hybrid. But precision is a little bit less in the hybrid. And the reason is that because we tune, or because we optimize for no context, some of that mass, so to speak, ends up going towards precision. So we get a little bit of a lesser precision here. But notice that recall is an important metric for us, because essentially recall says, of all of the documents that we were looking for, how many of the documents that you found were actually relevant? And we wanted to, indeed get all of the documents. So even though we lose out a little bit on precision here, we felt that overall our hybrid scheme gave us much, much better performance from the perspective of evaluating this rack system with well-known metrics. So hopefully that answered your question, Nicolette.
Absolutely. Did you find anything surprising in it, Vijay, or did this system we constructed operate as desired?
In this particular case, the system did operate as desired. Sorry about that. The system did operate as desired, and we did not find anything that caused us concern. Remember, for RFP, we do want the human to be in the loop. If you are serving a rack system that is serving frequently asked questions, we might have more leniency there. But on this RFP system, we did want a human in the loop. And when the human indeed did go through the answers, we across both of the clients, we did not find any surprises, which was, at least for us, a good sign.
Awesome. We love no surprises when it comes to AI generation. Excellent. So what happens next, Vijay and John? Can we envision a world where we're no longer spending this much time and energy and heartache over manually filling out RFPs?
Well, maybe. There's some things that we need to continue to look at, particularly around scalability. Fortunately, the corpus that's required for the use case that we've just been through was not very large, maybe some dozens of documents. But there are use cases where we might have to scan thousands or tens of thousands or even millions of documents. And we have to be sure that our algorithms remain efficient at that kind of scale up requirement, and that the inference costs don't get out of hand if we really need to search amongst that amount of source data. We could also have some better tools. Much of the data that we tend to find for these kinds of use cases is in a file system. It's not totally well organized. It may be difficult to verify the metadata for age and currency and version, particularly, as I said earlier, in documents that might change rapidly. So we need to pay attention to that too. And we need to look for other places where this kind of approach works. It was easy to identify the approach for the RFP, RFI, audit document kind of use cases, but there are probably others that would fit just as well, given that we can solve for the issues around data quality, latency, scalability, and so on.
Makes sense. I'm going to ask you a bonus question really quickly, gentlemen, just because of something Vijay said earlier. You mentioned that it really comes down to choosing the right LLM, or maybe even LLMs. Can you talk a little bit about how one goes about that? I assume they're not all created equal.
Correct. All LLMs are not created equal. So I think the general rule of thumb is that the more parameters an LLM has, the more resourceful or expressivity the LLM can exhibit, or the more reasoning it can do. So one of the metrics that we consider when we take a look at a RAG request and see what it's going to be serving is to determine have some idea of complexity of the questions that the users are going to be asked. As an example, we also ran a RAG experiment internally in the company where we put up some information on documents that talked about APIs for the FreeClimb platform itself. And these APIs are available publicly for those of you that develop on FreeClimb. You can use these APIs and develop them, develop applications yourself. But we are interested to see how we could jumpstart, let's say, a junior programmer to come and create a FreeClimb application. So one of the things we did was we took all of the corpus that we have of our APIs and put those up, and then created a RAG system out of it. And then you could ask the questions of the RAG system along the lines of, how do I create a callback in FreeClimb? Or how do I cause FreeClimb to make an outbound call? And then it would give you the code, right? The Perkle code that FreeClimb uses to allow applications to drive the platform. So when you're looking at that, clearly a 32 billion parameter model might not suffice, but a 70 billion parameter model might do good. Now, there's some judgment that comes in for the data scientist who's doing this analysis to try to understand what is the difference between 32 billion parameter, what's the difference between 70 billion parameter, what is it that we're going to be asking this LLM to synthesize. And that judgment obviously comes with experience. But as I said, to answer your question, Nicole, I keep calling you Nicole, my apologies. Nicola, to answer your question, not all LLMs are created equal, but I think experience and insight on the data scientist part can actually guide this discussion on which LLM might be appropriate for which particular example, given the complexity of what the LLM is going to be asked to do. So if the LLM is going to be asked to actually synthesize responses from many different documents, then you want something that has at least 70 to 100 billion parameters. On the other hand, if it's going to be asked to synthesize or reword a fact, you might, or frequently asked questions, then you might just end up using something along the lines of 20 or a 32 billion parameter model. I hope that sort of answers your question.
Absolutely. And just as a follow-up, you mentioned, your data scientists working with this. Is this a attempt with data scientist only type of technology? This is not something I would cook up in my office for sure, but is this something that you really need a data scientist to build and operate? TBD?
I think that's a good question, and to a certain extent, I would make the case that we want our technology to be at a point where, just like a car, you can pop up the hood, see everything seems okay, put the hood down and just drive it. We do want our technology to be at a point where others who are not data scientists can create these RAG systems. But at the same time, I think there is some level of expertise and some level of insight and experience that's required to choose the specific components that go into a RAG system. I think that part, choosing the right components, is the more data sciencey part, so to speak. Once you've chosen the components, the rest is integration, and that is much more easier to do for people who may not necessarily have the data science background, but do have interest in creating these systems. But to choose these components, I would come out and say that some, familiarity with the domain in general and the specific artifacts in particular, like LLMs and embedding systems and token lens and chunk lens, is something that'll stand you well.
That makes so much sense. So getting an expert to help you choose the ingredients, but then others can follow the recipe and cook up something great. Makes sense. And for everyone who is not lucky enough to have a Vijay in their life, we'll make sure we include some contact information when we send out the recording. Excellent. Okay, with that, friends, we've got a couple of questions from our viewing audience. And if anyone wants to add a question to the chat, it is open. So first and foremost, security, obviously a hot topic. You said the word AI. We also need to say the word security. What about it in these new RAG systems and this approach?
Well, you have a number of approaches. You can apply the usual compliance checks. So if you're dealing with information that might contain PCI, you need to run it in an environment that's PCI compliant, HIPAA for health and so on. And the big decision often is, do I want to share the proprietary information that I'm using, my corporate data, with a third party whose infrastructure I can't see? Our preference has always been with FreeClimb to run it on our own infrastructure, which we can see and which we can ensure is monitored and secure. We do use external services if that's what a customer wants, but we have to take extra precautions if we do that, encrypting data in transit so it's not visible between us and the third party, and contractual requirements for the third party to say what they're going to do with the data, where they're going to put it, and when are they going to get rid of it if we don't need it anymore. So it gets a little more complicated. Security remains an issue, but the simple answer is do it yourself. You still have to have good security hygiene, but it's within your control.
Right. I'll add one more thing to that. I think John hit the most important parts of security with respect to integrity, confidentiality of the data. There's also this, once you open up a RAG system to the rest of the world, then you know you'll be attacked, for sure. The question then is going to be, what are the attackers going to be attacking? Well, the attackers are going to be attacking the RAG system itself, all right? Trying to jailbreak it, trying, to cause it to give answers that it was not designed to do. So some of the work that we are exploring within FreeClimb research is trying to understand the behavior if we were to treat for instance, each question and an answer as a graph and try to understand the behavior and the transitions between the graphs to try to then figure out, okay, maybe this user is lingering on this particular node for a longer time than they should, and then try to do something proactively. So security comes in many aspects, the data security that John mentioned, but security also means how do we prevent these crackers or hackers from actually jailbreaking your LLM and causing it to do things that you do not want it to divulge.
Makes a lot of sense. Thank you. We have a lot of people on the call who are interested in knowledge management in general. Shouldn't all knowledge management consider a RAG approach and this multi-layered RAG approach? It's hard for me to imagine a scenario where RAG isn't the right answer for knowledge management.
So it's a useful tool to add to the knowledge management kit bag, right? The knowledge management's about a lot of things, including the fancy stuff like ontology and taxonomy, where you're trying to organize things so that the things that are most like each other show up in approximately the same place, which actually makes the RAG kind of approach more efficient in that we can cluster the source documents, the knowledge, into previously defined areas so that we are more likely to know where to go look for the answer than having to scan the entirety of the underlying knowledge base. But in terms of getting questions answered, the reason why you might accumulate the knowledge base in the first place, yes, absolutely. A RAG approach, an LLM assisted RAG approach is absolutely a tool that everybody should have access to.
Are people doing that in the industry a lot today?
You see a lot of noise about it. I'm not aware of a huge number of functional examples yet. But the thing you run into, if you remember what our three challenges were, you have to make it go fast, otherwise people won't wait around for the answer. So there's a range of use cases that we're not yet really well resourced to attack. And it's been known for at least 50 years that corporate data quality is not all that good. So there is a fairly significant initial lift to ensure that the knowledge you put in the knowledge management system is real, accurate, timely, and has permissible use characteristics.
Very good point. It's that whole idea of garbage in, garbage out. You've got to start with having some good, solid knowledge.
And our models actually generate their own garbage. So as Vijay said, we have to be very careful about how we curate the answers that they provide.
I'm just thinking this, though. Wouldn't it be just thinking through just how much documentation some industries generate? I'm thinking government, financial, healthcare. We're talking even more than the New York Times bestsellers that Vijay referenced. Couldn't RAG help us even figure out what needs to be updated? If it's really that good at provenance and finding it, is that another use case? Can it also make us smarter and better?
I think it can make us more efficient. Making us smarter might be a challenge.
That's a really big lift to ask any system. Great point. Efficiency is good, though. Excellent. Are there any other questions from our viewing audience? Vijay and John, is there anything you'd like to add about our work on using multi-layered RAG for RFPs? Or really, I'd say any highly constrained business process that might be a little bit of a document and word heavy lift?
Well, we've used the RAG approach on more than just RFPs. As Vijay said, the frequently asked questions automation is a somewhat simpler. It's got some complexity of its own, but it's a somewhat simpler process. And we have a number of examples where we've been able to use the same approach to provide answers to a spoken request as well as a typed one. And that chain of capability from talk to ask the question through to speak the answer is a very interesting area that we see a lot of people wanting, and that we've been focused some effort over the last year or two to make it stable and scalable and cost effective.
Excellent. And I'm going to ask a funny question when we're talking about RFPs. What's most exciting in this space as you're developing these approaches and architectures, Vijay? It doesn't necessarily need to be RAG specific. I'm understanding the high efficiency and accuracy benefits of it, but what really gets you excited in this space?
So the interesting thing in this space is, just the penetration of the LLMs in areas of businesses that we are using. I think to me that has been a very interesting development as I see it. You can ask an LLM today a very mundane question to something that is more esoteric. And because, as I said, they've been trained on pretty much everything that the humankind has ever written, it'll give you an answer. And most of the time, that answer is right. Now we are coming up with these reasoning LLMs that give you a peek inside on how they are reasoning. That is another interesting aspect for those of us who are, cognitive psychologists or linguists. This reasoning peak allows us to see, does the LLM mimic, how humans reason, how humans learn? So that's another interesting part of it. One other interesting part we're doing with these LLMs is basically trying to understand how we can, how should I say, control them to a certain extent. There's work that has gone on with OpenAI as well as Anthropic on what's called MECINTERP, or mechanistic interpretability. And that's the idea that we want to see, can we control these LLMs to the point where we can depress a button or press a button and have the LLM do something, a function of that button. So if that button is going to be a sycophancy button, when I press it, anything the LLM says is just, oh, you're great. Your question is great. I could not have phrased it better. If I undepress that button, then the LLM goes off the sycophancy route, right? So what we've been looking at recently in some of the work that we've been doing with these LLMs is how can we find out those buttons that are apparent in textual LLMs today? How can we find those buttons for voice-based embeddings? And what can we learn from those voice-based embeddings if we had a button that we could push and the embedding of the voice can tell us something interesting? So one of the buttons that we have found out is we can tell from the embeddings that a certain voice belongs to, let's say, a Spanish speaker, but the speaker is actually speaking English with a Spanish accent. So this might be interesting for a wide variety of business use cases. So there's all these, all this work going on in the LLM area that to me is the most exciting part of trying to understand how are we going to build products that are going to make our customers' life, much easier.
It sort of sounds like we're giving LLMs a CAT scan and really understanding what levers to control and making that all kind of transparent. Very cool.
So on a more mundane level, wouldn't it be nice to know if filling in an RFP in a certain way improved your chances of winning the business? And if we can get the outcomes of our RAG systems attempts to provide the answers, and we can map the structure of how that question was answered to the outcome, then we can have the RAG system make suggestions about how to answer questions that would improve your chances of winning.
Now that's even more than efficiency. That's actual intelligence and really improving our shots of RFPs being accepted and even chosen. Outstanding.
Yeah, and it works not because the RAG system is essentially intelligent. It's because it's able to process large amounts of data that help us predict outcomes. And if applying that capability, the ability for, you can think of it as a cheap form of reinforcement learning, saying if you do it this way, we win more often than we lose, then we've got a positive business outcome that results directly from the ability of the RAG system.
Good clarification. It's still efficiency. I just did not know that efficiency could be so sexy when used with RAG. Who knew? Excellent. Thank you everyone for joining us today. We'll make contact information, the academic paper, and some additional content available with this recorded webinar. Just as a quick bonus, Vijay, you working on anything else cool? Any other projects in the hopper that we might do a future webinar on?
Yes, my team is working on aspects that I described earlier on this mech and Turk. We are also working on ways in which we can create these, what we have called in the past micro models. These are automatic speech recognition models or other models that are light enough that based on the FreeClimb programming API, you can load in and out of memory really fast. And because they're light, they can actually share memory with many other applications running on the GPU. You don't have to dedicate the entire GPU to just that one application. And we are also looking at TTS systems and how to make them better. So there's a bunch of efforts that are going on within the team that I lead that touch on LLMs and other aspects of NLP and AI.
Amazing. So we were here today talking about RAG for RFPs and how exciting efficiency can be. You heard some of our upcoming work. Let's stay in touch. Thanks for joining us today. We'll send everything out and have a great rest of your day. Thanks, everyone.
Goodbye, everybody.
Thanks. Goodbye.